Don't know much about algebra. Don't know what a sliding rule is for. But I do know one and one is two. This one could be with you. Oh, wonderful world this would be.
Welcome back, everybody. I hope you are having a great day. I know it's a little bit cloudy and gray outside, not the best weather, but I still hope nonetheless you are having a good day, a healthy day, a fun day, a productive day. And I am excited to dive into Mr. K's 30 minutes of math. So with that, let's get right in to our riddle from yesterday. I'm going to stop the video so I can focus on that. All right, so as you may recall, our riddle had this pizza-looking shape, and we had a number of different numbers in the pizza shape, in each wedge, that is. And I'm actually, one second, I'm not sure that you guys, if you are seeing the riddle, can you go ahead and let me know? If not, I'm going to share it once again. Let me just do that just to make sure, because it looks like it's not showing up on my screen. So hold on one second. Let's try this one more time. And we'll do that. And we're almost there. And let's see if we, all right, that's better. That's much better. Okay, now we can get going. All right, so we had our pizza-looking shape with different numbers in the wedges or the pizza slices. You get the idea. And the question is, what number goes into the question mark? What should fit in there? And so we have to sort of think about a pattern that is existing in this pizza shape. So there's lots of different ways you could think about it. You could, for example, I don't know, split it up into quarters and see, do each of the quarters add up? I don't know, let's see. That would be 33, and that would be 17, and that would be 15. That doesn't really tell us much, so that's, oh, that didn't work quite right. Let's get rid of all of this. What else could you do? Well, you could split it up in halves. Let's see, 11 plus 7, that's 18. And then 18 plus 8 would be 26. And 26 plus 4 would be 30. All right, let's check this side. We'd have 13 plus 17 equals 30. Oh, we're going to be way over. So I'm not even going to finish because that's going to be way more than 30. That didn't work. So you have to kind of keep trying until you see something that does work. And so I will show you what the solution is. Okay, the answer is 20. The answer is 20. Let me go ahead and put that in so we don't forget 20. And the reason it's 20, it's pretty clever. If you add the numbers in the opposite slices, so those two right there, I told you the answer is 20, so I'll just go ahead and do this one. That would be 20 plus 4 equals 24. But you didn't know that it was 20, so let's check some of the other ones. Let's try this one here. 11, and its opposite here is 13. 11 plus 13 equals 24, so that one works. Let's try this one here. 16, and its opposite slice is 8. 16 plus 8 equals 24. That one works. Let's try this one. 7 plus 17. And that one works. So we see a pattern, and then we could infer, we could figure out, deduce that if this is 4, this has to be 20 to make it add up to 24. All right, well done to everyone who was able to solve that. Let's dive into our homework from last night. As you may recall, we had an aquarium that we were solving some problems with. This time we have a penguin nursery. It's open 2 times a day, 2/3 of an hour at noon. Okay, so whoops, let's use this one. At noon, it's open 2/3 of an hour. And then we know that it's 5/12 of an hour in the afternoon. So let's go to that one. Afternoon. It's open 5/12 of an hour. How much time is the penguin nursery open every day? All right, well, we have 2/3 of an hour at noon, 5/12 of an hour in the afternoon. We want to know how much it's total open. I see some folks have written in 1 and 1/12. Let's take a look. We have 12ths over here. Let's decompose those thirds into 12ths. To do so, we are going to multiply by 4. And 8/12 we know is the same thing as 2/3. So 8/12 plus 5/12 gives us 13/12. And we could do some number bonds, 12/12, that's 1 whole, and then we'd have 1/12 left over. Well done, guys, well done. All right. Let's go ahead and do another one. And I'm going to give you some music, give you a chance to work on this one. The coffee cups can hold 7/9 of a pint of liquid. If Emily pours 2/3 of a pint of coffee into a cup, how much milk can a customer add? All right, I would encourage you to draw this one. As I said yesterday, drawing is really helpful for these problems. Okay, welcome back, everybody. So I started off the drawing. Here's my beautiful coffee cup. Thank you very much. Actually, I'm going to put some coffee in it. There it is. All right. And we know that it can hold 7/9 of a pint of liquid. So when it's all filled up, it holds 7/9 of a pint. And the question is, if Emily pours 2/3 of a pint into a cup, how much milk can a customer add? Meaning how much is left over. So if she puts in 2/3 of a cup, now I'm just estimating this, so don't worry if it's not exact. She puts in about 2/3. The question is, how much milk can she put into the empty space that's left? Well, if we start off with 7/9, that's how much it would be all filled up. And then we pour in 2/3 and we want to know what's left. Let's take away the 2/3 and what's left is the empty space for the milk. Well, we're going to convert decompose our thirds into ninths, and we know 2/3 would be 6/9. So we'd have 7/9 minus 6/9, which equals 1/9. You have 1/9 of a pint left over for your milk. Well done, folks. Well done. Fantastic. Let's do one more before our joke. Go for it. Okay, welcome back, welcome back. I drew a few pictures just to try to help us out. I'm sorry if my pictures aren't the most beautiful in the world. My apologies, and I'm sorry that the milk is yellow, which is not very appetizing, but I wanted you to be able to see it. So let's read this. The capacity of 2 milk pitchers is 9/10 of a liter each. One pitcher has 3/8 of a liter of milk, and I've drawn that right here. And the other pitcher has 5/12 of a liter of milk, and I've drawn that one, whoops, right here. How much milk is there altogether? And this one is interesting because they tell you that the pitchers can hold 9/10 of a liter, but that's not really important information for this problem. All we're going to do is add up the amount of milk that we have, which is 3/8 and 5/12 of a liter. The question is, what should we decompose these fractional units into so that we can add them up? I'm going to go with 20/4. And to do that, we're going to multiply the numerator and the denominator by 3. So we have 9/24, and then 5/12. Hopefully you see that we're going to multiply by 2. 10/24. So 9/24 and 10/24 gives us 19/24. 19/24. All right, well done. I see a couple folks got that. That is fantastic. Very proud of you guys. All right, let's get to our math joke of the day. Here we go, friends. What did the wizard say when he removed the frog's spell? What did the wizard say when he removed the frog's spell? All right, welcome back. What did the wizard say when he removed the frog spell? He said hexagon. I like that one a lot. Hexagon. A hexagon is a six-sided shape. There's a hexagon right there. Or it could be like that. So I thought we'd do a little bit of our geometry with hexagons. So welcome back to our coordinate plane. We have our hexagon, and here is my question. Let's do this. Here's A. Let's call this B, C, D, E, and F. Okay, my question is, what are the coordinates for each point? Go ahead and do that. Take a minute to determine the coordinates for each of those points. Okay, welcome back everybody. Let's go ahead and take a look at our coordinates starting with A. And we always begin right here at the origin. Well, let's see our X coordinate. We're gonna go -1, -2. And then we're gonna go +1, 2, 3, 4. So -2, +4. That's A. Now let's do B. We're gonna go +1, 2. And we're gonna go up. So 1, 2, 3, 4. All right, let's do C. I'm gonna switch to green so you can see it. 1, 2, 3, 4. And we don't go up or down. So this one is 0. Well done, you guys got that. I'm really, really happy with that. All right, D. Let me use, I'll go to red. 1, 2, for the x-axis, and now we're going down, so it's -1, -1, -2, -3, -4. And then E, we're going left, -1, -2, and we're going down, -1, -2, -3, -4. And finally F, and I'll do that in yellow, we're going left, -1, -2, -3, -4. And we are not going up or down, so we are at 0. Well done, well done. All right. So now my question is, let me get rid of those. And let's get rid of this. And let's bring out the ruler. All right, here our ruler is. Let's draw a line. Let's go with blue. Here we go. Whoops, I just got rid of my A. We didn't want to do that. Let me put our A back. There you go. And our ruler, let's draw our line. And remember, lines go on forever. So we put those arrows, meaning they continue. All right, so the question is, what is the slope of that line? The slope, remember, steep slope, shallow slope. And as you recall, the slope is the rise over the run. The rise, how much we go up, and the run, how much we go across. So go ahead and type in what you think it would be for the line that connects F and A? What would our slope be? Our rise over our run. Go ahead and take a second. I see Ezra writes in 4/2, little tank, 4/2. Let's check out, see how they did. 1, 2, 3, 4. That's our rise. And 1, 2, that's our run. 4 halves, which is the same thing as 2. And that should make sense because look at this other way we could have done the slope. We could have done 1, 2, 1, because there's a point right here. 2/1 is the same as 4/2. So different ways of getting the same slope. All right, one more. Look at this one. It's a little bit more squat. All right, so please go ahead and determine the coordinates for these points: A, B, C, D, E, and F. Go ahead and take a minute to do that, and we'll be right back. Okay, welcome back, everybody. I see folks have already started to write in, and I'm seeing some great answers. Let's check real quick. A. All right, we're going to start at the origin. Here we go. 1, 2, 3, 4 to the left, which means it's -4. Now we're going up. 1, 2, 3, 4, 5. Excellent work. B, we're going to the right. 1, 2, 3. It's a +3, and we're going up. 1, 2, 3, 4, 5. +5. C, we're going to the right. 1, 2, 3, 4. And then we're going up. 1, 2, 3, +3. D, I'll do that in yellow. 1, 2, 3, +3 to the right, and up 1. That's positive. E, 1, 2, 3, 4 to the left, and that's negative. And then 1 up, which is positive. And finally, F. 1, 2, 3, 4, 5 to the left, that's negative, and then up. 1, 2, 3, that is positive. Well done, guys. Really well done. Really well done. All right. Now what I want to do is just one more slope, but this one's a teeny bit different. So let's bring our ruler back. I know you guys are enamored with our ruler. All right, so this time I want you to find the slope of this line. Let's do it in yellow. Let me move it a little bit closer. Whoa, that was a crazy line. Okay, and it goes on forever. And I want you to think about whether your rise or run is positive or negative for this one. Rise over run. Go ahead and take a minute to think, what would our slope be for the yellow line connecting B and C, thinking about whether our rise and our run are positive or negative. Okay, some folks said they can't see the line. I'm sorry about that. Let me do it in a darker color so folks can see it right there. So here's B and here's C. Well, let's look at our rise. We're going up, 1, 2. And our run is 1 to the left, 1 to the left. Oh gosh, I do see that it's not showing. So let me stop my share and then share it again. I'm so sorry about that, guys. Let's see if we can get it back. 1 second. Maybe it just timed out or something. We'll bring it back in a minute here. Okay, now we've got it. That's the line that I'm talking about. So our rise, let me do that again. Our rise is 1, 2. And our run, we're going to the left, so it's -1, -1. So what you'll notice is that lines that tilt to the left like this end up being negative, and lines that tilt to the right have a positive slope. So that's just an interesting thing. We can talk a little bit more about that tomorrow. All right, I do want to, we're gonna skip over those. Let's do one more of our fraction problems. Go ahead, give this one a try. We'll be back in just a minute. Okay, welcome back, everybody. Let's take a look at this. We have a large cookie, my half-hearted attempt at a chocolate chip cookie, 5/6 of an ounce, and a small cookie, 4/9 of an ounce. We have 2 large cookies and 1 small cookie, so 5/6 plus 5/6 plus then 1 small at 4/9. So this would be 10/6 plus 4/9. And let's decompose these 6 and 9ths into, let's go with 18ths. Times 3 times 3, so we'd have 30 18ths for this one. And then we have 4/9. And we'd multiply by 2 to get 18ths. So 8 18ths for this one. 30 18ths and 8 18ths is 38 18ths. Woo! All right, number bond time. 18 18ths, that's 1 whole. another 18/18. That would be 2 holes, that's 36. And then we'd have 2 more 18ths left. So we'd have 1 and another one, 2 holes and 2 18ths, which is the same as 2 and 1/9. All right, I'm checking to see if anyone was able to get it. All right, I see Ezra got it. Fantastic, so excited, fantastic. All right, here is tonight's homework. The coffee shop also sells small bags of coffee beans. The bags come in 2 sizes, 4/5 kilograms and 7/12 kilograms. How much more coffee does the bigger bag have? So 4/5 and 7/12. How much more does the bigger bag have? All right, let's go to our riddle of the day. This is a thinking one and also a math one. Let's say you won a special lottery ticket that has 2 payout options. The first option is $1 million right now. The second option is 1 penny today, but then you double it to 2 pennies, and the next day you double it to 4 pennies, and you keep going, but you stop after 30 days. The question is, what is the better deal? Option 1 or option 2, and why? You have to prove to me what your answer is. All right, thank you everybody. It was so much fun to see you all today. I can't wait to see you tomorrow for Friday's Mr. K's 30 minutes of math. Have a great day, everybody. Bye.